Hi everybody, I'm going to go over the Chapter 6 notes for Math 95. Those notes were in an email I sent out this morning, Tuesday, and they're also in Lumen in two places, under the Chapter 6 notes and in the yellow block at the top with this week's dates in it. So I'm going to go over those today, and I'm going to do it a little bit differently. I'm not going to go over all of the notes because several pages of them toward the back are examples for you to try practice problems. So I'm going to go over the first few pages, the first few examples of the graphing, and then I'll post the completed notes and you can check your work from there. We really went over all that new stuff today in the Zoom session. So Thursday's Zoom session will really just be any questions anyone has, any of them that someone wants me to go over. So I won't do an extra video on Thursday. Okay, so this will be the only video for this week. So in Chapter 5, we were graphing and we were using a point plotting method. We'd find x's, or we'd choose x's, and then we'd figure out what the y value would be for that. We'd get an ordered pair that way. That worked for any kind of equation. So we could do it for linear equations, we did it for absolute value equations, we did it for quadratic equations. In Chapter 6 now, we're only dealing with linear equations, and we're learning a different way that we can graph linear equations. So if you look at the top of page 1 of the notes, it's just a little bit of a review at the very top about knowing where your axes are, the origin, quadrants, knowing how to plot those points. So again, I'm just going to refer you to the completed notes to check your answers for those. But then right below that, we start talking about the slope of a line. So if we talk about the slope of a line, another word that can describe what we mean is the steepness of a line. And I often in class explain this by thinking about stairs. So let's say you go to an old house. Maybe your grandparents live in an old house and you go up into the attic. Well, those attic stairs probably look something like this, right? They're tall, they might be narrow, so your foot kind of almost doesn't even fit on the stairs. But that's what they look like. Now, think about, in contrast to that, if you go to a museum or some large building like that, and they have those really wide stairs out front. Okay, so we can tell that this staircase is much steeper than this staircase. So we want to think about why that is. Well, in these attic stairs, there's a much larger height to every stair, and also a larger height compared to the width of the stair, right? So it's very vertical. With these, it's a small vertical height for a larger horizontal height. So the slope goes along with that, okay? The slope is the steepness of a line, and mathematically, it's the ratio, okay? A ratio is a comparison of two things. We often write it as a fraction. So it's a ratio of the vertical change to the horizontal change. So let's think about what that means. That you finish getting that down here. It's the ratio of the vertical change to the horizontal change. So it's how far up I go from one point on the stairs, from the bottom of one step here to the bottom of the next one. How far up do I go compared to how far over do I go? So we use M for slope, to stand for slope. Okay. So one way we can write this, which looks a little crazy at first, but you might have encountered this in your science classes. This is the Greek letter delta. It looks like a triangle, and it means a change. So we say this is change in y. Remember, y on the y-axis goes up and down, so there's my vertical change over change in x. So it's the vertical change over the horizontal change. Okay, or another way we can describe this that you might remember is rise over run. Okay, so these words again describe how we move. Rising, we rise up or down, right? An elevator rises. And then if it goes the other way, it will go down. We run, we don't run up in the air, we run across. So The run number tells us where we're going left or right. So what this means, and this will make more sense once we see it in context, but what the slope tells us from one point to the next, how far up or down do we go, and how far over left or right do we go. And that gets us to the next point on the line, or to another point on the line. So these are kind of descriptive ways of talking about the slope. We'll use this one when we're using the slope. But if we need to find the slope, we also are going to have a formula. So we're going to have m equals y2 minus y1 over x2 minus x1. This is going to be our formula slope. Sorry, our slope formula. Formula for slope. Okay, well, what are these x's and y's? Remember we said the slope tells us how to move from one point to another point. So to do this, we will use 2 points. And we know that our points are ordered pairs, x, y. But just to make it a little easier to label them, we're going to say, okay, well, this point I'm calling point 1, so I'm going to just call those parts x1 and y1. And the other point, I'm just going to call x2 and y2. It's not squared, it's not an exponent, it's what we call a subscript. Written down at the bottom, it's just a label. So if you want to just think of the slope formula as y minus y over x minus x, that's fine, okay? We'll just see that we have to be consistent about which one we use first, which point, and we'll see that in just a minute. Okay. So I'm going to wait just a second if you're still copying any of that down, or you could just pause the video to get the rest of it. But that is what we need to know about slope in terms of finding it. Now we're also going to talk about what we call the slope of different slanted lines. So if I have a line that is going in this direction, it's going from left to right, it goes from down to up, then that has a positive slope. Okay, so if we think about that, if I have 2 points on this line, to get from one point to the other, I have to go up, and then I have to go to the right. Both of those are positive. Going up on the y-axis is positive, going right on the x-axis is positive. If I have a line that is slanted in this direction, now it could be this way, it could be steeper, it could be shallower, but generally from left to right going down, this is a line that has a negative slope. Okay, so again, if I think about mathematically what's happening, to go from one point to the next, I go down and right. Well, down is negative, so I would have a negative number over a positive number. Negative divided by positive is negative. That's why the slope, the number for the slope, will be negative. All right, the next one is if I have a horizontal line, this has a slope of 0. Okay, it doesn't have no slope. Its number of its slope is actually the number 0. The reason for this, if we think about mathematically, I have 2 points. So rise over run. Rise, it doesn't go up and down at all between those 2 points. So that's 0. And then I have some number for the run. Whatever the number is, 0 divided by anything is 0. And then finally, I'm going to put the fourth one up here, I guess. If I have a vertical line, this is what we call an undefined slope. If something is undefined in math, it basically means that it breaks some mathematical rule, so it doesn't exist. So the reason this doesn't exist is, again, if I think about 2 points, rise over run, it has some rise value, some number that it goes from here to here, then it doesn't go left and right at all. I would have to divide by 0. I can't divide by 0. So that's why this is not allowed. So that's why it's undefined slope. It doesn't have a slope. Okay. So what you need to be able to do is to identify these. If you have a line going in this direction, you need to know that it's going to have a positive slope. You're not going to be able to tell just by looking at it what the slope number is. We'll have to do some work to find that. But if you graph something and we know ahead of time that its slope is 2/3, that's positive, it should be going in this direction, not in this direction. Okay, so a little trick to remember, I don't have a trick to remember positive, but to remember -0 and undefined. If you have a line that's going in this direction for a negative slope, you should be able to make an N out of it. It's slanted in the way of that middle line of an N. So you might guess the other two already. This one is like a Z. You can make a Z out of that line. And this one, you can make a U. Okay, so just a little trick to remember which is which. Okay, so on the notes, we did that middle section of the first page. We talked about the slope and how to find it, which we will practice in a minute. And then we just talked about the other, all the different slants for a line. Okay, so then the bottom of page 1 there, we have a couple of examples of actually finding the slope. So in order to find the actual slope, which is a number, we're going to use that slope formula of y2 minus y1 over x2 minus x1. So I'm going to put that up here. So again, remember we said we need 2 points. Well, these aren't really labeled, but or numbered, but the question right below the picture of the slopes says find the slope of the line that goes through the points 1, 3, and 4, 9. So our 2 points are going to be 1, 3, and 4, 9. Okay, now generally we can do this without graphing, but let's just graph a little sketch here. Just so we know what we're looking at. Okay, so 1, 3 would be right here, right? I'm assuming I'm counting by ones here. And then 4, 9 would go over to 4 and up to 9. Okay. So then, these are those 2 points. Once we have 2 points, that's all we need to make a line, okay? If I only had 1 point, if I only knew this point right here, there are an infinite number of lines that go through that point because I could draw a line this way or this way or this way or this way. Once I have 2 points, there's only one straight line that can go through those. So here's my straight line. I want to know what the slope of that line is that goes through these 2 points. There's only one possible slope. If it had a different slope, it would be tilted slightly differently. So I'm going to use these 2 points. So I'm just going to say, okay, this one is point 1. So I'm going to call those x1 and y1. And this one is point 2. So I'm going to call these x2 and y2. And I'm going to use this slope formula. So y2 minus y1 is 9 minus 3. x2 minus x1 is 4 minus 1. That gives me 6 over 3, or that reduces down to 2. So my slope for this line is going to be 2. Or, often we keep our slope, as a fraction. It could be 2 over 1. Okay, now let me show you one other thing. What happens if instead I called this one 0.2 and this one 0.1? Because the order, I could have given them in the other order in the problem too. Let me just show you that it's fine if you switch the order. So in this case, I would have 3 minus 9 and 1 minus 4. I would get -6 over -3. 2 negatives divide out to be a positive. I get the same thing. So it doesn't matter which one you start subtracting as long as you do the same order. If I do this minus this for the y's, I have to do the same for the x's, or vice versa. Okay, I'm going to stop this video so it's not too long to upload. And then in the next segment, I will start with the next problem right below that and move through the next couple pages. All right, thank you.